given y is equal to 3x minus 1 whole square plus 2x minus 1 whole cube, find dy dx. Now the previous problem I had forgotten to record. Okay, so just take a note of this. I'll just scroll the screen so that okay, so that's how. Start with the next one. So given here problem, if y is equal to, given here is if y is equal to this, find dy dx and the points on the curve for which dy dx is equal to 0. Okay, so very quickly, this differentiation is a cakewalk. Given y is equal to 3x minus 1 square plus 2x minus 1 whole cube. Therefore, dy dx will be equal to, first you differentiate this to get twice, differentiate the power first, twice 3x minus 1 into the ddx of 3x minus 1. Next, you differentiate the power of the next expression into ddx 2x minus 1. Check whether you understood the differentiation. Next, twice 3x minus 1, ddx 3x minus 1 is simply 3, plus thrice 2x minus 1, ddx 2x minus 1 is 2. Okay, so this is 6 times 3x minus 1 minus 6 times 2x minus 1. You can take 6 common, you get 3x minus 1 minus 2x plus 1. So minus 1 plus 1 will cancel, 3x minus 2x will give you simply 6x. Okay, so you get dy dx is equal to 6x, and the question is find the points on the curve for which dy dx is equal to 0. So dy dx is equal to 0 means what? 6x is equal to 0. That means x must
Yes,
be
sir.
equal to 0. So that means x coordinate is 0. Now we need to find out the y coordinate also, right? So therefore, y is equal to, put it here in the given equation. This is the equation of the curve y 3x minus 1 whole square. So 3 into 0 minus 1 whole square plus 2 into 0 minus 1 whole square. That is, this is at x is equal to 0. Y is equal to
It will
this.
be
How much?
2, 2.
Okay, 2. So you're getting only 1 point, right? The question is find the points on the curve, but you're getting only 1 point. Okay. So the required coordinate is, the required point is
0, 2.
0, 2. That's it. Okay. Move on to the next problem. If y is equal to 5x by 1 minus x to the power of 2 by 3 plus cos square 2x plus 1, show that dy dx is equal to 5 by 3. Let me write in the next line. It's a little long. Show that dy dx is equal to 5 by 3, 1 minus x to the power of minus 5 by 3, 3 minus x minus twice sine 4x plus 2. Okay, so this looks like a little long, but it actually should be very easy. So given y is equal to 5x by 1 minus x to the power of 2/3 plus cos square 2x plus 1. Differentiate this. Therefore, dy dx is equal to 5 times ddx of x by 1 minus x to the power of 2/3 plus ddx cos square 2x plus 1. Now we are going to differentiate this. First, we are going to use u by v rule. So v you have into ddx of u. What is ddx? What is u? U is x. So ddx of x is 1 minus v u, sorry, u into the ddx of, let me write here, ddx of 1 minus x to the power of 2/3 divided by v square. That means 1 minus x to the power of 2/3 and the square of this. Okay. Plus ddx cos square 2x plus 1. First differentiate the power to get 2 cos 2x plus 1 into, and then differentiate whatever is within the cos. Okay. So now, okay, we need to differentiate the cos also. We differentiated the power here. We differentiated, see, here we differentiated the power here, 2 cos 2x plus 1. Next, it should be ddx of cos 2x plus 1, not only 2x plus 1. Right? So now, we'll see here, 1 minus x to the power of 2/3, you'll get here, minus x times, if you differentiate this, you get 2/3 into 1 minus x to the power of 2/3 minus 1, which is minus 1/3, into ddx of 1 minus x, which is minus 1, divided by 1 minus x to the power of 4 by 3 plus, now ddx of cos is what? Minus sine, right? So minus twice sine 2x plus 1 into, yes, this is simply sine, not 2. ddx of this is minus sine, and this will be twice cos 2x plus 1 into ddx 2x plus 1. Right? So now we are going to simplify this. In order to simplify this, what you do here is you have 1 minus x to the power of 2/3, right? Minus, you write this as 2x by thrice 1 minus x to the power of 1/3, right? And this minus, I have a minus 1 here. These two minus signs are going to combine to give me a plus sign. Divided by 1 minus x to the power of 4/3. Now you take the LCM in the numerator. If you take the LCM in the numerator, you're going to get thrice 1 minus x to the power of 1/3 and 1 minus x to the power of 2/3 into 1 minus x to the power of 1/3 plus 2x, and that's going to be 3 here also. Okay, whole divided by 1. Oh, sorry, I forgot to write the second part. So you have a, or not only here, but you also have a minus twice sine 2x plus 1 cos 2x plus 1 into ddx 2x plus 1 is simply 2, right? So now this is, now you take the LCM. Thrice 1 minus x to the power of 1/3. So you get thrice 1 minus x. This is to the power of how much? 2/3. So this is thrice 1 minus x to the power of 2/3 into 1 minus x to the power of 1/3. If you take the LCM, plus 2x whole divided by 1 minus x to the power of 4/3. And here you see 2 and 2 will combine to give you a 4. Or better still, what you see here is, this is what form? 2 sine theta cos theta, right? Which is sine 2 theta. So this is sine twice, and theta here is 2x plus 1. And you have a 2 here, so this 2 will come here. Okay, so this entire thing combines, right? So you get 5. Now you simplify this side. You get thrice 1 minus x plus 2x. And this goes to the denominator to get thrice 1 minus x to the power of 1/3 into 1 minus x to the power of 4/3, which is equal to 5 times 3 minus 3x plus 2x. Okay, divided by thrice, and here if you add up the powers, you're going to get 1 minus, sorry, again I forgot to write the second part, minus twice sine 4x plus 2. So now here you have thrice 5 times 3 minus 3x plus 2x divided by thrice 1 minus x to the power of 1/3 plus 4/3 is 5/3 minus twice sine 4x plus 2. And we have got the answer. So you get 5 times in the numerator. What are you getting? 5 by 3 you take out, and here you're getting this 1 minus x to the power of 5 by 3. You write it in the numerator, so the power becomes negative. And this one here, 3 minus x minus twice sine 4x plus 2, and that is what was required for you to prove. Okay, fine. One last sum from this, and I cannot start implicit functions today, so I'll start implicit functions tomorrow. Differentiate. This is a simple one, not as a difficult one. Root over of a plus root a plus x. We have got two radicals. Say let y is equal to root a plus root a plus x. Therefore, dy dx is equal to, first of all, let me write this as ddx first, and then I'll root over of a plus root a plus x. I'll first differentiate this radical. Okay, to get 1 by 2 root
2 root is
a plus
a
root a
and
plus
a
x, right? Into the ddx
plus
of whatever is inside the bigger radical, a plus root a plus x.
a plus root a.
Now this is 1 by 2 root
2 root
a
under root
plus root
a
a
plus
plus
root
x
plus a.
into, now if I want to differentiate, the ddx of a is constant, ddx of a is 0 plus ddx root a plus x,
By 1 by root under a.
which is 1 by 2 root a plus x only. So this will be 1 by 2 root a plus root a plus x, okay, into ddx of root a plus x is 1 by 2 root a plus x,
2
into
root under
ddx
a
a
plus.
plus x, which is 1, into ddx a plus x, which is 1, we all know. Okay, so this, your answer should be 1 by 4 root a plus x into root a plus root a plus
A
x.
plus.
Or better still, can write this answer as 1 by 4 times. You can take a plus x inside the radical to get a plus x into a plus root a plus x. Express it as a single radical. You get 1 by 4 root a into a plus x plus a plus root a plus x into a plus x is a plus x to the power of 3 by 2, right? And so you finally get your answer. So 1 by root a square plus x plus ax plus a plus x to the power of 3 by 2. Okay, I've just shown you how to simplify. You can leave your answer here also, or you can leave your answer here also. No problem. Okay. So I'll stop here.